For number 18, we're given these two parametric equations. And first we want to eliminate the parameter to obtain an equation x and y. And then we want to describe the curve and kind of say the positive orientation. So what we're going to do here is we have these two equations. X is equal to square root of t plus 1 squared. And y is equal to t plus 2. To eliminate the parameter, we first have to isolate t, either in terms of x or in terms of y, and then plug that value of t into the other equation. So the easiest way to isolate here is by isolating the y, right? Because if I were to isolate the x, I have to take the square root, and that would be plus or minus. So we're going to isolate t in terms of y. So therefore, t is going to be equal to, I'm going to bring the 2 to the left-hand side, so that's y minus 2. So once I have a value for t in terms of y, I'm going to plug that in here because then I eliminate the parameter t. So this means that x is going to be equal to t, but t is y minus 2 plus 1 squared, which therefore means that x is equal to, that's going to be y minus 1 squared. And previously our input was t, right? So we could see here that t went from 10 to minus 10, and now we're just going to adjust the input because now the input is no longer t. The input here, we're treating it as y. So that means that y is going to be equal to, if I plug in the lower boundary minus 10, so let me erase some of the stuff so that we can see it clearly. If I plug in the boundary minus 10 for t into the y equation, I'm going to get that y is equal to minus 10 plus 2, so y is minus 8. So that would be the lower boundary for y. And if I plug in 10 into the equation that relates y and t, so that's the upper boundary for the input, we're going to have that y is 10 plus 2, so y is 12. So this over here is our parametric equation expressed in x and y. So what we have to do now is we have to describe the curve. So this x is equal to y minus 1 squared. If you plug that into a graphing calculator, you're going to see that this is a parabola that opens up, it opens up to the right. So it actually is a parabola that's been shifted up. It kind of goes like this. So we're going to say a parabola which opens to the right. And now we want to say the positive orientation. So the positive orientation means that we're describing where the point where it starts and the point where it ends. So begins at. So we can see that y, our input, is going to begin at minus 8. So if y is minus 8, let's see what x is going to be. X is going to be equal to, that's minus 8 minus 1 squared. So x is equal to, that's going to be minus 9 squared. So x is equal to 81 when y is equal to minus 8. So it's going to begin at this point, 81 comma minus 8. That's the beginning, right? And that corresponds to the value of minus 10 in t. So if you were to plug in minus 10 in the y and the x equation, you would see that you would get the point 81 comma minus 8. And now we're just going to test the upper boundary where it ends. So the upper boundary is y is equal to 12. So we're going to plug that into the x equation. So x is going to be equal to 12 minus 1 squared. So x is equal to 11 squared, which means that x is 121 when y is equal to 12. So it begins at the point 81 comma minus 8 and ends at the point. So x is 121 comma 12. So that is it. We were able to describe the equation of this parabola, the shape that it has, and where it begins, the point, the coordinates of the point, and where it ends. So that's it for problem 18.